All right, let's do it. Like I said, we're going to do some definitions, but then we're going to apply them, which is the important part, because I'm never going to ask you to give me, like, define a term or anything like that. We don't do that. But the sort of three things we're looking at, or maybe it's just two things. Domain and range, so you've seen that before. We're going to review those and talk about whether something is a function or not. Okay? All right, so what is a relation? A relation is, so you just want to copy this down, a set of ordered pairs so an ordered pair would be like x comma y. Okay. And often we write them as equations. So a relation could just be a list of points, but we never work with that, so I'm not even going to bother really doing. We'll see one, I think, but that's it. It might even just be in the work. There's one in the lesson too. But we usually write them as equations, because otherwise you're listing an infinite number of pairs. And usually it's not just a relation, there's a relationship between x and y. You could have a set of points and there's no relationship between x and y, it's just scattered points. You could have that, okay? But we are interested in the ones that are a relationship. There's some pattern between them. Y is always twice as big as x. That would be a simple one from grade 9. Something like that. Okay? So the domain is the set of all x values of a relation. And the range is the set of all y values of a relation. So all you have to remember is domain means x and range means y. But you do have to remember that part. Don't get them backwards. You remember doing domain and range? Like vaguely at least. You've heard those words and you remember that you did it. You may not remember exactly how you do it, but once we review it, you probably will. It'll kind of start coming back to you. But you probably don't really get why. Like, why? Who cares about the domain and range? And that's tricky. I don't have a great answer for you right now, because quite frankly, you need to learn a little bit more math before you could really understand why domain and range matters. But the quick answer is, eventually we start comparing different functions to each other. And different kinds of functions. What's similar between them? What's different between them? Just like if you were comparing two people. What's similar between them? What's different? They have the same hair color, different eye color. One's got a black mask, one's got a blue mask, right? Like you compare, one's tall, one's short, or they're the same height, whatever. Those are properties of people, and we use them to compare people sometimes. Well, domain and range are properties of functions, and we can use them to compare functions to each other. And different functions can have similarities and can have differences, right? All quadratics share some properties. You know the quadratic is the parabola. It's the one that looks like this. And all parabolas either look like that or look like that. Like they all have that same general shape. They all have the same domain. They have different ranges. So this is the point of these domain and range, but it would make more sense if you continued to do more math and got into it at a bit of a higher level than where we're at right now. And then you start to kind of get it, like, oh, now this actually makes sense. Now I actually see the point of this. It's really hard to learn something when you don't see the point to it. And in fact, a lot of students in math class say, why am I learning this? When am I ever going to need to know this? Why am I, right? And there's not always an easy answer to that because you're not going to see it for a few more years. Why you're really learning it? What's the point? It makes it harder. It really does. So anyway, I don't know if that helps at all, but try not to worry too much about why we're doing domain and range. We are just going to keep doing it, and domain is X and range is Y. A function is a relation where, I'm going to say a technical definition that might not make much sense, but then I'm going to explain it in words that will make more sense. For every X value, there is a unique Y value. Or in other words, when I say unique, obviously I mean only one Y value. Okay, so we're answering the question, why do we care about functions? And as I was just saying, it won't impact you. Whether something is a function or not wouldn't really have an impact on your life, even in math class. But it turns out whether or not something is a function is important in mathematics. And I'll try to explain why. So I'm going to draw two relations. And I'll write their equations. Ooh, I'm going to do this the fancy way. See if I can get this to work. Haha, nice. So the one on the left is what? Parabola, quadratic, y equals x squared is the one that I made. The one on the right is obviously a circle. You may have seen circles in grade 10. Sometimes you do a day on it. It may not have happened because stuff got cut when things got shut down. That's the equation of a circle. X squared plus y squared equals 4. That's the equation of that circle. But they look like that. One of these is a function and the other one isn't. So parabolas, quadratics are functions. Circles are not. Why are circles not functions, and who cares? Here's the reason why. When I pick an x value, the way these relationships work is we get to pick the x, put it into the equation, and calculate the y, right? That's what we do. So somebody give me an x value. Just name a number. 12. If I put 12 into this, I square it and I get 144. So if x is 12, y is 144. And I can calculate the y value that way. Because x values only have one y value. That's not true of the circle. Pick an x value less than 2. How about 1? Okay, so this is 1. If you say, I want to know the y value for 1, and you're asking the equation can't give you that answer because it might be up here or it might be down there. So if you're like, I need to know what the answer is for 1, when you have something that's not a function, it's going to say, I don't know what it is. It might be this or it might be this, but I can't tell you for sure what it is. So for a function, when you give it an x, you get a y. For something that's not a function, you don't necessarily. Okay? You don't know for sure that you've got the right y. Imagine you went to a store and their payment system worked on something that wasn't a function. So payments work on function. You buy 3 apples, you pay per apple, right? So you go to checkout and they say, it'll be $5. You pay them $5. If you go to a store and it's not a function and you buy 10 items and they're like, well, we can't tell you how much it is because we don't know if it's this one or this one. You're like, well, what kind of a stupid system is this? That's a simple example, but that's what it means to not be a function. It means you can't answer the question definitively. It might be this or it might be this. So this is why we care in mathematics. This is why we care about something being a function or not. You don't really need to know this. You do need to know if something is a function or not because it's part of the course curriculum. But that's the reason why we care. So it turns out there's a really good reason. But it doesn't really come up in high school mathematics that it impacts us and the work that we do. So on the back of that page, you should have all of these graphs. We're going to state the domain and the range and determine whether each one of them is a function. So we're going to look at all different kinds of domains and ranges. And then we are going to determine whether they're functions. And when we're talking about that, there's a very easy way of telling if something is a function. So that wordy definition for every x value, there's a unique y value, isn't necessarily the best way to think about it. There's a better way. It's the vertical line test. So if you can draw a vertical line that cuts through, so it's got to be straight up and down, that cuts through 2 points, then it's not a function, right? Because then I have 2, and in fact, I'll do it. Oops. So there you go. When I draw a line through 1, it cuts it in 2 places. So that relation fails the vertical line test because it doesn't have only one y value for each x value, right? So it's not a function. And that's how you're going to tell. Basically, are there 2 places where the line, the relation, is on top, directly above the other one? That's what it means to not be a function. Okay, first one looks like a straight line. What's the domain? Now, we haven't actually done one of these yet, so we have to talk about how we know what the domain is. This is the question I like to ask, and I think, especially when you're new to this, you've done this before, but like returning new, this can be a good way of doing it. There's 2 different ways, 2 different questions you could ask yourself, 2 different ways you could look at this. One of them is, what are all the possible x values? What could x be? Okay? And then the other one is, are there any x values that this function will, or this relation will never touch? Are there any x values that it cannot be? And you can answer this question in plain language. We're going to do the formal symbol version afterwards, but first you got to think to yourself, just in normal language, what the answer is. What do you think? Are there any x values that this line will never go to? Yes? Like what? But this one's going this way. It's not going to touch the axis. That's not what we mean. What I mean is, if I pick -4, will this line hit -4 somewhere? Yeah, look, it hits right there. Right? Because it's -4 all along that spot. Does that make sense? Good. So I'm glad you brought that up because that's, why didn't that stuff erase? Important to understand. So are there any x values this will not be? I don't think so, because it's going forever that way and it's going forever this way. It's going to hit every single x value eventually. It's going out both ways. Right? That's what domain means. All the symbol stuff is just fancy math language. But what domain means is it's going to go out both directions forever. There are no x values that it will not touch. Now, how do we say that? In the math language, we say x is an element of the real numbers. We use the squiggly brace brackets. You have to use those. They don't have to be drawn nicely. This e It's like it looks like a capital E, but it's curved, means in. And that's called the double bar R. And in mathematics, they use it to represent different kinds of sets, and it means the real numbers. So what it means is x can be anything. That's what it means. And in fact, if I ask you what's the domain of this relation, you can say x can be anything. Like you could use that language. I'm totally okay with that. Writing it on a test, I want you to write it that way. So when you tell me x can be anything, I say, oh, okay, good. And I'll write that down. So you got to know how to write it, but that's how you could say it. What about range? Is there any y value that this will never touch? Okay. Yeah, so it's going up all the way. And that's what those arrows mean. It means going on infinitely. Right? It's a good way of putting it. It's going on forever. It's going up everywhere. This one is going up forever and right forever. Your right is this way. This one's going down forever and left forever. Right? So in both cases, x can be anything and y can be anything. Pretty easy for that one. Is it a function? Does it pass the vertical line test? Can you draw a vertical line that will touch it twice? So those arrows mean whatever it's doing now, it's going to keep doing. You don't put an arrow on something and then eventually it turns back around and does that again. Okay? Can't do that because then the arrow is kind of lying. So, yep, it passes. This is definitely a function. This is a linear function. You do those in grade 9. Next one. Domain and range. So we'll just talk about domain. Are there any x values that it can't be? Or is it going off to the right forever and off to the left forever? Looks like it is, doesn't it? This one's going off to the left forever. That one's going off to the right forever. And there's no values in the middle that are missing. It touches all of them. So I think domain is the same as the last one. X can be anything. What about the range? Are there any y values that it can't be?
Anything below -2.
Why do you say that?
Because both the arrows stop at -2.
So both arrows are pointing up. And it stops at -2, and it looks like it's not going to turn back and go back down. It's never going to turn back down. So this function, or this relation, I should say, because we haven't talked about whether or not it's a function, this relation will never go below -2. It's a great way of describing it. We're going to write the fancy way, but that's how I want you to think about it and describe it. Okay, so that's exactly right. So we still start with this. X is an element of the real numbers. Again, you probably don't know why we say that every time, but that's because it could be an element of some other kind of number. It could be the integers, it could be whole numbers, it could be imaginary numbers. And so again, if you were doing more math, you would have to say what number system you're working in. Okay, we always work in the real numbers. So we always just write that. But then we put a line, a straight line. The straight line stands for, anybody remember? Such that. So y is an element of the real numbers such that y, so we said y can't be less than -2, but we say y is always greater than or equal to -2 is how we say it. So we write what y is, even if we talk and think about what y can't be. Kind of opposite, you know what I mean? And some people have a hard time with these symbols, and they do them backwards all the time. Don't know what to tell you. You got to practice. And when you're checking your answers, look and make sure that your answers, your symbols, look like the ones in the answers. And if they're backwards, yours are wrong. You can't just do it your own way. There's only one way to do these symbols. Okay? And the big side points to the bigger thing. So this is saying y is bigger than negative 2 because the big sign is pointing to it. That's the easy way of thinking about it. Big side points to the big thing. Y is bigger than negative 2. Is it a function? Does it pass the vertical line test? Can you draw a vertical line through it that'll cut it twice? You can draw a horizontal line through it that it can cut it twice. Right? Some people might have been thinking that. We don't care about horizontal lines, we care about vertical lines. There's no vertical line, so yes, it's a function. Okay, next. That one looks familiar, right? So we're going to do domain, range, and state whether there's a function. Now, this one can be tricky. And I'll tell you why. Some people say, well, I don't think x can be anything because those arrows are pointing up. They're not pointing left and right. Whereas these ones look like they're pointing left and right and up and down. These ones just look like they're pointing up. But it can't go straight up. Those are not going straight up. So even though they look like they're pointing up, they are still drifting out, aren't they? The x's here are still getting bigger. So that's it when x is 1. When x is 2, will be some value up above. Right? So you like if your visual intuition is stuck on those are pointing up, not left and right, you got to figure that out. You got to like train that out of yourself. That arrows are almost always pointing diagonally somehow. So they're pointing up and left or up and right or down and left and down and right. Almost always. Okay? So this one is going to the left and this one is going to the right. So don't you think that makes our domain the same as the other two? X can be anything. There's no x values that won't work for this. Okay? Don't worry, we'll see some that aren't like that soon. What about the range? Are there y values that this will never be?
Anything that's below -4.
Right, so this one goes down to -4, turns and goes back up. So y is an element of the real numbers such that y will always be greater than or equal to -4. Okay? Any questions so far on any of that? Is it a function? Yeah, it's a function. Good. Don't be shy answering questions. If you get it wrong, you get it wrong. You're not supposed to know everything. You're not supposed to get all the answers right. We're just learning this. People are always worried about making mistakes when they're learning something new. Why would you expect to know everything and get everything right when you're learning something? You know what I mean? Like, you shouldn't be worried about it, because I think a lot of people probably had a gut. And don't get me wrong, you don't have to answer questions, or just nodding is fine. But if you're wrong, it's fine. So, be willing to answer. But even if you don't want to answer out loud, have that gut feeling, recognize in yourself, say to yourself, I think it is. And then I'll give you the answer and you can tell whether you were right or wrong. Take a look at these two. They don't really look like each other, do they? But is there anything similar about them? What do you think?
It's the fact that they both have an area where they meet together, but instead of continuing to go down, they end up separating. The only difference is the one looks more sharper, I guess.
Yeah. So they do, look, they have the same domain and range, except it's a different value. But otherwise, they have the same domain and range. So this is what I mean by we can compare different functions using these properties. And what we mean by that is they both have sort of some y value that they start at and go up in both directions. So this one's starting here and going up both ways. This one's starting here and going up both ways. The difference is this one's straight lines and it's a sharp corner like you were saying, whereas the other one is a smooth curve. So they have some similarities and some differences. Okay, let's keep going. Next. What does that look like? Yeah, it's a parabola, but it's fallen over. It's lying on its side or something like that. Okay? So this is not a quadratic, because quadratics have to be like that, opening up or down. But this is obviously similar in some ways and related to that parabola in some ways. Okay? So what is the domain and range? What do you think the domain is? Is there any x value that it will never be? Is it going to the right forever and to the left forever? It's not. Jay, what do you think?
It's going to stop at -3.
So at -3, it's never going to go past that. It's never going to go to the left of -3. Domain is looking at the left and right of the graph. Both of the arms of this thing, if you want to call them arms, are pointing in the same direction. All these other ones, they were pointing in opposite directions. So this one's different. So this one's going to be x is an element of the real numbers such that x is greater than or equal to -3. Now, I'm using the equal to sign. I didn't mention this before. I'm using the equal to sign because it does touch -3. We can assume that it does get to this point. But it's not going to go past it. What about the range? Is there a y value that it will never be, or is it going up forever and down forever? And it's going to be the same thing. These both look like they're pointing to the right. But isn't this one also going up as it goes to the right? And this one is also going down as it goes to the right? So one's going up, one's going down. It's going to hit all the y's. So y is an element of the real numbers such that nothing. Such that nothing. Just y is an element of the real numbers. Stop. And if I compare that domain and range to the domain and range of the parabola, what do we notice about them? They're kind of flipped. The domain and range kind of traded places. I mean, it's a different number, but essentially otherwise it's the same. So that's interesting. That's why they kind of look like each other. Is this a function? Or can I draw a vertical line through it that will touch it in two places? Let me get my vertical line out. One, two. Fails the vertical line test. Not a function. Again, the reason why it's not a function is seen really nicely here. I'm going to pick a different value actually, because I'm going to pick one where we can see the values just so we can talk about it. Hey, where's my ruler? There we go. So if I want to know what for x value of 1, what's the y value? There's 2. It's either 0 or 4. So it's got 1 in 4 and 1 in 0. Same x value. 2 y values. That's what it means to not be a function. And the reason why is what I explained before. We don't want this to happen. When I ask, what's the y value for x equal 1? I want to get an answer. Not a, well, it might be this or it might be that. That's the power of a function. So not a function. Aha, circles. So circles are going to, this circle is going to be quite different in terms of its domain and range. This is the first one we've seen like this. This is the hardest one to write for a lot of people. Are there x values that this will never touch, or does it go forever to the right and forever to the left? Royce, you say no. You're saying there are values that it won't touch. Is that right? And what do other people think? Miriam, you were kind of nodding your head too. You think the same thing? You agree with that? Yeah, it's closed. So it's never gonna. It's not like it goes around and then eventually goes wee off or something like that, right? Like that's not what's happening. So it's never gonna hit any of those. And it's never going to hit any of those. All the x values, how could you describe this one? All the x values are where? How would you describe, with your own words? If you were explaining this to somebody, what would you say? All the x values are between, all right? 4. Why did you pick 1? Four is one part of it, yep. -4. Right? Because it goes all the way to those. So from -4 to +4. All the x values are between -4 and +4. Some of them are up here. Some of them are down here. We don't care about the height, because that's y. Y is a measurement of height. We care about just the left and the right. It goes from -4 to +4. So here's how we write that. X is an element of the real numbers such that I start with the smallest, I end with the biggest, and x has to be between them. Because you just said to me, x is between -4 and +4. So when you write it, x has to be between those values. That's a good way of remembering that. Now you got to figure out which way the symbols go. When you have a restriction on both sides and it's between them, you always start with the smallest and end with the biggest, and the symbols always go this direction. You can memorize that, or you can think about how that means -4 is less than +4. The way we would say this is -4 is less than x, which is less than -4. And -4 has to be less than 4, right? Because it just is less than 4. What about the range? Any y values that this can't be, or does it go forever up and forever down? Same thing. It's always between -4 and 4. So we would write it the same way, but with a y. But y is still between 4 and 4 in my answer. Is it a function? Or can you draw a vertical line that cuts it twice? Not a function, you think? Let's test it. I mean, you don't need to actually get a ruler to do this, but looks like you're right. Because all these lines that I draw, I can draw a whole bunch of lines that'll cut it twice, right? All along there. Now, if I go past it, it cuts it 0 times. That's okay, that doesn't matter. Functions don't have to go on forever. But it's not a function because I'm cutting it twice in all the places where it is, basically. So not a function. Stop me if there's any questions, otherwise we're going to keep going. What about this one? So this is a straight line. What's different about this one and the first one that we did?
The first one goes on forever, the next one stops.
How do you know this one goes on forever? Arrows. Tell me it goes on forever. I like how you describe this one. This one stops. This one has boundaries. This one does not go on forever because it doesn't have arrows. So it's not just x is an element of the real numbers. X is an element of the real numbers such that, so just looking at x, ignoring y, where does it start and where does it stop? watch, if you want to watch, you could do this. Draw a vertical line. What's this x value? -4, right? So that's the smallest. What's this x value? 3, +3. So that's the biggest. X is between them. And the symbols always go that direction. They always go that direction when there's two numbers. They don't always go that direction when you do the other ones. For these ones, we as a rule, I won't mark it wrong necessarily, but it's weird. We always start with the Y first and have the letter second. That's just a standard. So it's not wrong if you wrote it the other way, but it's a bit weird. Y is an element of real numbers such that, does it go up forever and down forever? No, it stops. Where does it stop? Where does it start? So what is this Y value? And what is this Y value? Good, so it goes from -2, it's always between -2 and +3. Is it a function? Or does it turn back and go over top of itself? It doesn't do that, does it? So anywhere I draw a vertical line, I'm only going to hit it once. So yes, this is a function. Okay, are we good? We got a few more, and they are all kind of different in different ways. Okay, so keep that in mind. They are all kind of different. So that's why we're doing so many examples. So again, some of you might find this easy. Some people are visual and they just get this. Some people are not visual at all, and they just have a hard time making the relationships between these things. So it's at least helpful to them that we continue to do this. If you think you can do the next ones on your own, you can go ahead and try, but make sure that if you get it wrong that you fix it. So, domain. Is it going to the left forever and to the right forever? Miriam says no. Why not? Good. And it's only going right forever, not left forever. Very good. So it has a place that it starts, but then it goes on forever. So we're going to say x is an element of the real numbers such that, so what are the x values that it will never be? It will never be below -4. Because that's where it starts. So x will always be greater than or equal to -4. Kind of like this one. This one had two arms, but they're both pointing the same direction. This one's only got one, but it's the same idea. Range. Y is an element of the real numbers such that, what's the condition on Y? Miriam already told us it's going up forever, but not down forever. So it'll always be bigger because it's going up, that's getting bigger. It'll be bigger than something, and that something looks like -2. I'm going to give you a hint. When you're doing, I think both our examples do this, but they don't, in the work they don't. Just because x is getting bigger doesn't mean y will be. These signs don't have to be the same. Okay? There's no reason why domain and range have to have the same signs like that. That's just the way it might work out. Is it a function? Yes, good. It is a function. because you can't draw a vertical line through it that cuts it in two places. I get the feeling people are starting to get a bit more confident about that, which is good. Okay, you can try this one on your own if you think you can do it. So this one's going left forever and down forever, but not the other direction. So x will always be below positive 3. It'll never be bigger than positive 3. It'll never be 4. It'll never be 5. A really good strategy, if you're stuck on a question, is pick real numbers. Say to yourself, well, is it going to get to 4? Is it going to get to 5? Is it going to get to 6? No. Those are getting bigger. It's not getting to those. But it will get smaller. It'll go to 2. It'll go to 1. It'll go to 0. So it's getting smaller. Right? So it's always going to be, if it's getting smaller, it's always going to be less than something. So x will be less than or equal to. And that value looks like 3. And same thing for y. It's pointing down, that's getting smaller, and looks like the cutoff is 3 again. So if you tried that yourself and you got those two and you got the symbols pointing in the right direction and everything like that, good for you. Is it a function? Yeah, it is. We got one more. If there's any questions, let me know. So this one looks like it's always pointing to, if you're trying it yourself or if you've already done it, that's great. You know, you can watch. This one's always pointing to the left, but it's not going to the right. Is that true? And it's pointing up, but not down. Is that true? Again, that one kind of looks like it's pointing left and not pointing up, but it's also going up. It is also increasing, going up that way, right? So it's going left and going up. It's not going right and not going down. Going left means the x values are, see, this is tricky. Because it's pointing up, people think it's getting bigger. But what are the x's doing? 1, 0, -1, -2, -3, -4. The x's are getting smaller. So even though it's pointing, even though it's going up kind of, the x's are actually getting smaller. So x will always be less than or equal to 3. But what about y? The y's are getting bigger. -1, 0, 1, 2, 3, 4. They're not getting smaller, they're getting bigger. So they will not go below a certain value. Okay, so, oops, frozen. So, what was I saying? So it's going up forever. There are y values below it that it will never get to. So y will always be bigger than or equal to, it looks like -2 to me. So there is an example of where X is going one direction and Y is going the other direction. Okay, and this one is also definitely a function.